In this video, we're going to cover the key concepts that you'll need to be familiar with before we dive into the more complicated aspects of circular functions. To start with, we're going to explore the differences between degrees and radians and how to convert between the two of them. Then we're going to cap off our discussion with a review of how we calculate the basic trig ratios sine, cos and tan. For those who don't know me, my name is Chris Iannozoni. I used to work as an engineer for a defense company, and I've since left that to start a career in tutoring. I make these videos so that VCE students can do the best they can in math methods. With that out of the way, let's get into it. Before we can understand the relationship between degrees and radians, we first need to introduce the unit circle. The unit circle, simply put, is just a circle with a radius of 1 that is centered on an axis. So the center of our unit circle is going to be the origin, and each of the axes intercepts are going to occur at plus minus 1 because the radius of the circle is 1. Now that we understand that, let's have a discussion about radians. Radians is a type of angle that is measured with respect to the circumference of the unit circle. So if we consider the circumference of a circle to be 2 pi multiplied by r, when you think about the unit circle, it has a radius of 1. So the circumference of the unit circle is just going to be 2 pi. What this means is that instead of saying that we have 360 degrees inside of a circle, we instead have 2 pi radians inside of a circle. For another example, we can say that a semicircle has 180 degrees because it's half of the 360 degree circle. In radians, that would just be pi, since it's half of the 2 pi in radians circle. This relationship between degrees and radians allows us to convert between one and the other. If we know that 360 degrees is the same thing as 2 pi in radians, then we can put an equal sign between them, since one is the same as the other. From here, we can rearrange this equation in two separate ways. Once to get radians on its own, and another time to get degrees on its own. These are the formulas that we use to convert between radians and degrees, or vice versa. So, suppose that I want to convert 3 pi over 4 to degrees. Well, using the conversion formula, I see that all I have to do is multiply by 180 and divide by pi. After a bit of simplification, we see that this comes to 135 degrees. At first, it can be a bit confusing which equation you use, whether you multiply by pi over 180 or by 180 divided by pi. The way I like to remember it is that radians has pi in it. So if you want to convert to radians, you want to put pi in it and divide by degrees. Whereas if you want to convert to degrees, you want to multiply by the degrees, 180, and divide by the pi to get rid of the pi. One more example, but in the opposite direction. This time I have 270 in degrees, and I want to convert that to radians. So, just like I mentioned before, since I want to convert to radians, I want to multiply by pi to put radians in it, and I want to divide by 180 to take the degrees out of it. The three trig ratios that you'll need to be familiar with are sine, cos, and tan. If you aren't already aware, these ratios were written with respect to the side lengths of a triangle like this. The hypotenuse is defined as the longest side length of the triangle. The adjacent side is defined as the side where the angle intersects, and the opposite side is defined as the side where the angle doesn't intersect. You can see that the angle intersects only two of the side lengths. The opposite side is going to be the only one that it doesn't intersect. So that's going to be with respect to wherever the angle is located. These ratios can be memorized using the acronym SOHCAHTOA. The first letter of each section tells you which trig ratio is being discussed. S for sine, C for cos, and T for tan. The next two letters define the division. So for example, SO means that sine, S, is equal to the opposite, O, divided by the hypotenuse, H. The same can be said for the other two ratios. Now, let's have a look at how we use these ratios. This question here is asking us to simply just calculate sine of theta. To start with, we're going to take our triangle and then just label the sides accordingly. The hypotenuse is going to be the longest side length, so h equals 4. The opposite side is going to be the one where the angle doesn't touch, so O equals 2. From there, we're just going to use our ratio. We know that sine theta is equivalent to the opposite divided by the hypotenuse, and when you simplify that all the way down, you're just going to get sine theta equals a half. Now, we're going to have a look at how we can apply the ratios. This triangle here has an unknown side length that we want to calculate. And the information that we're given to calculate it with is the length of the hypotenuse and the angle of 31 degrees. It's worth noting that the unknown side length that we have is still important to the equation. it's going to be written as x as our adjacent side. So what we know is we have the hypotenuse, we have the adjacent, and we have an angle. The only trig ratio that has all three of those things in it is cos theta. So we're going to use cos theta for this question. All we're going to do now is rearrange to get the x on its own. If you're in a tech-free environment, you would have to leave this answer as is. But in tech active, you can actually force the calculator to evaluate this circular function. Just make sure that your CAS is in degree mode. On the TI Inspire, you're just going to click this icon here until it says degree or deg. On the Casio, it's pretty much the same thing, it's just located below as opposed to above. And from here, we can see that our length is approximately 3.43 centimeters, which makes sense when you consider the actual scale of our triangle. The last thing we're going to look at is how the trig ratios can be used to solve unknown angles. This triangle here has a hypotenuse of 4 and an opposite side of 2. The challenge here is that we're trying to find an unknown angle theta. So, since we have the opposite and the hypotenuse, we should know that sine theta will be useful for this question. But here's the issue. We don't want sine theta, we just want theta. So what do? Well, what we do is we take the inverse sine of both sides of the equation. And what that's going to do is give us theta on one side and then sine inverse of a half on the other side. For now, we're just going to leave it like this. In future videos, we're going to see how this can be simplified by hand, but for now this will do. If you do have a CAS, you can actually solve this in two different ways. The first is just to tell the CAS to evaluate sine inverse of a half. That will just give you your answer outright. But in later videos, you're going to see that the second option is actually a bit more relevant, where you put it into a CAS solve and then solve for x. Now you might have noticed that I've had to put a domain on that second option. This is beyond the scope of this video as to why I did that, but we will definitely cover that in a later video. The last thing I'll leave you with is a little tip. In math methods, your answer, the vast majority of the time, is going to be expected in terms of radians, not degrees. The question will specify whether it needs degrees or not, but if it doesn't specify or if it's ambiguous, then give your answer in terms of radians. If you found this video helpful and would like to see more, I actually have all sorts of additional resources available for free on my website. Just click the link in the description and you can access them here. And if you'd like my personal help, then consider signing up for the tutoring program. I offer the first 2 weeks free of charge so you can get a feel for whether or not this will be a good fit for you. Otherwise, I'll see you in the next video.